So earlier we saw the ways that perpendicular bisectors could interact with triangles to create some interesting properties with those triangles and just have interesting properties as they interacted with segments anyway. Well, perpendicular bisectors are not the only types of segments, rays, or lines that could interact with triangles to create some really interesting and profound properties. There are in fact three others. Like the perpendicular bisector, we can also talk about the angle bisectors that interact with triangles, and two other ones that you probably haven't heard of necessarily by these names, called altitude and median, although neither of them is going to be terribly unfamiliar, and one of them, if you're familiar with finding the area of a triangle, is going to be incredibly familiar just by a different name. So we've already talked about the perpendicular bisector. We're going to skip that one and going to go straight to the angle bisector. As we know from previously, an angle bisector splits an angle into two equal halves, and that can happen on any angle, but in a triangle, an angle bisector goes through one of the angles and then cuts that angle in half. Of course, a triangle has more than one angle, so we can talk about multiple angle bisectors depending on the angle that we're specifically looking at. We are going to see, as part of this section of the module, we're going to see some interesting properties of angle bisectors, specifically as it relates to just bisectors of angles generally, but then it will continue into the angle bisectors of triangles. The next type of segment that could interact with a triangle is an altitude. An altitude is a segment that runs through a vertex of a triangle and is perpendicular to the side of the triangle opposite that vertex. Go ahead, pause the video, copy this down, and then come back when you're ready to see an examples of some altitudes in triangles. So this segment is one that you've actually seen before, whether you've seen it as an altitude or not. Whenever we find the area of a triangle, we are actually calculating the length of its altitude, because the altitude can also be thought of as the height. Now we have an example of a triangle here so that we can guarantee that the lines that we're drawing in are actually perpendicular. But if we wanted to draw the altitude from the vertex that is currently at the top, perpendicular to the other side, well, we could just start at the vertex and drop a line perpendicularly. That is the altitude. But an altitude from that vertex is not necessarily the same as the altitude from another vertex. So we're going to go ahead and we're going to create a single set of things here, and we're going to rotate this triangle, which is why I have the line down there at the bottom of the screen, so that one of the other sides is horizontal, and we can look at the altitude through another of the triangle's vertices. In this case, it's the angle and the vertex that is up in the very top right near the word vertex. If we were going to create a line or a segment or a ray that goes through that vertex and is perpendicular to the opposite side, that altitude is actually going to go something like that. Let's move this over so that what we can see is that it may not intersect with the side, but it is perpendicular to the extension of the side, because the side that is now at the bottom of our screen is only that long. And so there's nothing that can go through that vertex that is perpendicular to that side that also intersects with that side. So it's just perpendicular to an extension of that side there. And the same thing would be true if we looked at the third side of the triangle, which we're not going to do. But those are the altitudes. Again, anytime that you're finding the area of a triangle and you're dealing with the height, quote unquote, of the triangle, it is the length of the altitude, the distance from the vertex to the side perpendicular to the opposite side perpendicularly, or to the extension of the opposite side. And the last type of special segment is the median. And the median is a segment that runs through the vertex of a triangle to the midpoint of the opposite side. Go ahead, pause the video, write this down, and come back when you're ready to see some examples of medians. So, if we have a triangle like this, a median is one that goes through a vertex and is guaranteed to intersect with the opposite side because we have a midpoint of a side. Let's call it there. Then it goes from vertex to midpoint of opposite side. The same is true if we start at the vertex in the bottom left. Again, these are just approximations, or the vertex in the bottom right. So these medians will always be on the inside of the triangle, but they go from vertex to midpoint on opposite side. As we've seen in isosceles triangles, sometimes these particular segments can take on multiple roles. From the apex of an isosceles triangle, we have seen many times that a median, a perpendicular bisector, an altitude, and an angle bisector are all the same segment. But in other types of triangles, they are not necessarily that way. And in an isosceles triangle, if it's not something that is coming from the apex or originating at the base, it is not going to be multiple segments all at the same time. So we have to consider each of these, the perpendicular bisector, the angle bisector, the median, and the altitude, as separate segments and separate interactions with the triangle unless we have already proven that they are the same. But as a quick review of what those segments we saw today are, median runs through a vertex to the midpoint of the opposite side, and altitude runs through a vertex and is perpendicular to the opposite side, and an angle bisector, as we saw before, just splits an angle into two equal halves.